Alrighty, I want to preference this by saying the reason why I started this whole idea off was truthfully because I've always wanted to work in F1, but don't a lot of people, you know what I mean, that are into it. So there's that, right? Anyways, uh, so the whole air injector idea is a entirely different idea that I came up with as a way to get around certain inefficiencies in volumetric efficiency from F1 rules for given fuel and air. Alright, as my dog tries to bite me, you know, but just pay attention. Anyways, that's where it came from, and I was trying to make the given engine more efficient by having the heat itself do work. The bottomer idea is pretty fucking new for what it's worth, you know. But like, especially when it's like, well, here's a nitrogen filter. You might not have known about this, but there's nothing saying I can't use a nitrogen filter, and there's nothing saying I can't use an air to air pre with a water to air pre with a air to air and water to air after, all in a very small, tight, compact little area. All right. So like, there are no rules against any of the things I have at all. Especially the elbow pin. The elbow pin was a whole other thing, where it's like, oh, that's been around since like the 1800s. If you didn't know, that's a genuine fact. Like, it's been around since the 1800s. But the reason why many people don't use it isn't because, man, I don't think it'll work, or it's so stupid, it'll break, or whatever else like that. It's mostly because other things got popular before, and they were really only used as a result of trying to increase given efficiency parameters of an engine, because back then they had huge low RPM trying to make up huge torques for like the lower compression and the huge amounts of fuel they were running with, and often they would try and use it from steam engines too, because like they just didn't have the type of internal combustion engine technology we have now, with the cooling that we have available to us now, and the given, oiling and everything else. A lot of it was all steam driven, so many people might not know, but they are probably very misinformed and believe I'm just blowing smoke up your butt, but that's because they don't have that knowledge. They'd have to look it up, but it is there. But that's only because I'm a person that's been interested in engines for a long time. So I picked it up along the way for a long time. But the technology, it's like, well, they're coming up with this inline four stuff, right? And like the whole idea of it in a harmonic balancer pump with the gearing along with their suspension as counterbalance weights was a way better way of introducing lower weights and reduced complexity and cost for higher performance. The offset crank with a larger crank with the elbow pin, which would have to be there anyways, and then the girdle itself with the two-stroke, kind of like all of it's just this improve efficiencies, cooling, and just remove parasitic loss. And if you think that I'm going to be able to get more torque from like the exhaust itself pushing, the answer is not really. Okay, I'm using its given heat in a area it can move to improve its efficiency at being able to push that piston back up, so I have less parasitic loss of a given size of flywheel, which flywheels are expensive in terms of weight to move around and keep moving around. And then I have a changing mass weight of flywheel at different RPMs. Then I have less of a need of counterweight, which means I have lower weight there too, even if there's a degree of increased complexity. Okay, so it's like, it's a way to remove some of the inadequacies of our current designs, but the way that we're introducing it, while some of it is complex to a degree, and has some degree of failure, I've yet to meet any engine that has no complexity and no degree of failure. Even turbines are something that fails. So I just don't think that that's a relevant statement, especially when we're talking we can always add redundancy, meaning multiple, to allow for multiple ways of continuing the system if there were to be a failure from one of the systems. It's just like, it adds cost. We're talking Formula One here. It was like, $10 million engines are fine. And it's like, hey, how much cost though? Not much, honestly. Like, for what it's worth, it's not as much as people think. It's just manufacturing changes. You know, it genuinely is like stuff that are already manufactured, and then it's just building it that way instead of a way before that we had it. So I'm gonna move off of that. So it's like the Formula One that I wanted to talk about was coming from like this donut video they put out today with this GT3R, and I was seeing like one of their pictures of the guy that basically removed their front end to pure and simple have just wait for the Australia. You know, they went down to Australia to talk about like the car culture down there, and I thought that was really cool. But it's like just to get more air into the radiator. You know what I mean? And I'm like, yeah, because and then I talked about it. I was like, oh, you can stack. Let's put another one there behind it. Like, it'll be fine. And for what it's worth, you still get better performance. You know, like, you still keep removing engine heat from doing that. Like, you think it's going to just totally overwhelm, like, the amount of cooling, you know, for that air going through, and it's not. Really, the problem is the mass. Mass becomes the problem. So you can absolutely do that and get more cooling, and it's not an insignificant amount. It's basically the same amount of cooling, but there's more mass now, right? So like that's the main drawback to doing that. And then I had a little joke about like, well, now we'll get the 7 foot by 8 feet radiator. And then they're looking at the GTR. Or like I'm looking at the GTR with like other people. You know, we're joking around like as if I'm there. And this is going on in my head, situation stuff. But it's like, yeah, we'll just hang it off the rear here instead, because we'll put the radiators in the rear instead of in the front, and we get better aerodynamic efficiency. Because like then it'll be hotter air on one side, and we'll separate the other hot air with cold air coming in from the top, you know, for the spoiler. All right, so it'll accelerate from a diffuser, and it'll be separated, and it's a big 7 foot by 8 foot ridiculous bullshit. No, are you kidding me? Yeah, sure, I can see from the rear. Oh yeah, it's a low fin density. I can totally see right behind it. You have side mirrors anyways. It's fine, guys. Look at the weight of this fucker. It's huge. It's basically the entire keeps it stable in the straights. Oh boy, does it. Oh yeah. When you want to take that turn, you know, it's like, man, does it really help getting that thing to give you like that like little slip that you're looking for to get around the corner easier. Is it overweight? No. Just put your driver and your engine a little further forward. That's how they'll equalize the. You know what I mean? Like I can always come up with some bullshit for it, right? But it's like at the end of the day, it's not necessary. You know what I mean? Because it would genuinely just turn into, why don't I just hang like a second radiator in the rear? You know what I mean? Like that's all that would really be. And then it's like, if you hit us. Which, by the way, it turns into, for me, if I was talking to the drivers, don't ever brake check people, you idiots. And that's when it turned into Formula One came in, like the ADHD distraction boy I am. Because it's like, they brake check people all the time. And it's like, well, you hurt my spoiler. And all my, you know, you brake check the shit out of me. Fuck yeah. That's crap. How am I the bad guy? And it's like, that's not what this is. You need to calm down. Oh, bull. Right? But then it's like, well, you know, actually, that does make sense considering they have smaller more thicker, compact radiators that are usually more efficient. And it's like, right, but all the weight would be up at the top. And it's like, right, yeah, oh yeah, no, but then it was like, oh, you know where that diffuser area is? I was like, oh yeah, no, I can put like radiators right there. They're angled with their fin density and arrays to help with downforce and the diffuser part to begin with. So I can put little gills there and like have it come up through the engine bay, right? But then it's like I have stacks of radiators lower down, and then I have a more compact. I can put the driver a little further forward, and I can have like the gas tank a little better further forward. But then I'm gonna get like I don't want to talk too much about it because like aerodynamics stuff is big deals, you know what I mean? Keep secret stuff, right? But it's like then I have air that helps cool the exhaust coming off of the engine because the engine's now going to have a rear mounted instead of front mounted intake, right? But it's like instead of all that other technology I was talking about, it just sort of bloomed into like that's where my the air intake and then this my water to air now it's going to be separated as I'll bifurcate the air coming out versus the air that's coming from these areas and I'll suck in the cold fresh air for my water to air over here for my intake or for the radiator, right, for the water to air. And I need it to be separated with an air heat blocker shield thing, right? So whatever, it's gonna be there anyways, right? And then it just sort of turned into a bunch of, well, actually, for what it's worth, they kind of do that already. Just FYI, the exhaust from that radiator area goes towards the exhaust tip and through that manifold from the side pods they use. And so like they'll have that come out, and that's why you'll see it just underneath where the spoiler is because it's lower density and it's traveling faster. But the problem is you want it to do a little bit better than that. You know what I mean? Like you would prefer it to be the entire size of that, right? And there are no rules against putting certain things that allow for that air instead of Venturi systems and all that to where I can have a radiator be there, like like another set of radiators, but then also like the exhaust is also there, and instead of it having it to be one tube, I could get away with having my little valve set up, my teardrop valve set up, and then have that be spread out, and then have a radiator nearby, but it's like tucked away, and then the standard just larger area of like a shroud around it effectively that you're not going to see that the radiator's there, right? But that means I can tuck in further forward that little inline 4 or even the V6 that they use currently. I can get it more tight and compact, and most of the weight's in the center and lower down anyways, which would improve all of their performance parameters that they're looking for aerodynamically and like outright in terms of weight distribution. Then on top of it I still get better performance from air coming through, helping with reducing that exhaust. Basically it just makes the engine a little bit better. Like I don't do anything to the valve. Nothing's going on, right, on that side. Like I wouldn't be doing anything to that. But I then, started going into my intake tech. So like that's the radiator tech. So it's like the radiator tech was like shoving it underneath and then having those little diffusers, and now they're stressed members, supportively stressed members to the chassis, the radiator. So like they're going to be built to be strong enough and also have like a little bit around them to be a functionally structural member of the chassis for the Formula One chassis, whichever one happens to do it, right? So that way I can get just better aerodynamics. It's like, oh, I still have side pods. You mean ginormous spoilers? That's where my radiators are. Are you sure? I don't feel like that's the truth. No, they are my radiators. That's for sure. They're my radiators. They're my radiators. No! Anyways, but like that's the name of the game in terms of being a competitor in Formula One, right? Like you don't want to tell everybody everything, but then at the same time, it's like no, it's the same. I swear, guys, it's the same. I swear, Z's. Winks. Nudge, nudge. And I can argue it with FIA all day too, because it's like those are really good crash structures. They will prevent like any hard, surfaced big radiators from possibly injuring the person inside the cockpit. Yeah, that's true. It would help with that. Hey. It's actually, yes, that will help them. I still though. Yeah, no, I get the anger, but then it's like that's just because you didn't think about it. That's the creative part of me. I was thinking about it, but it's like a lot of Formula One guys, while they're paid big monies, there's a given current way of thinking and doing something, and then while they might not know about something, and they might be very intelligent and creative on that stuff, it's like this is a old ass thing that nobody really used. You know what I mean? Like for a brief period of time, it existed. And it was very good at what it did. But then, why would I do that? We have this current, and this is all our time. You know what I mean? And it's like, I'm going to... And they're all honed in on that one thing, right? So they don't really maybe understand that they're missing this part that exists, right? Like, that's a thing they could do, but then they don't see that that's something that they're missing from this side. Like no, there's creativity, but then there's... Wait, what is that? You know what I mean? Like, yeah, right. Like, fucking holy shit. It's like, then it turns into girdle, and then bottomers, and then air injectors. Totally works, by the way, within the rules and scope of Formula One tech. It turned into, like, I have an inline four now that I have, like, a full dampening system, both front and rear. Along with my up and down suspension for counterweights, because like then that's a parallel. It's like they'll balance it parallel, right? So 1 and 2, 1 and 2, 1 and 2, right? And so then the harmonics are like 1 and 2, 1 and 2, 1 and 2, perfectly balanced. And then the bottomers just turn into, remember, I'm just taking hot air and then putting it, instead of blowing up your ass, which is kind of actually also sort of true, It's like, it's going to be vacuum insulated, all that. That exhaust has to be like that. Like it has to be insulated such that it doesn't cause your engine coolant to cool off the exhaust. We're not looking for that. But then it's like, that's why the fuel injector and then the air injector thing is such a big deal. And you can always get a bottle, but you don't really need it because then it's a super turbo concept, which it's like, I know this sounds weird, but when you can have a 120 foot-pound torque, 200 horsepower car run off of a CVT for a long time, then there's nothing stopping you from being able to use the same thing for a supercharger part for a super turbo. You know what I mean? Like, there's nothing stopping that. Same thing with the whole differential torque vector, where it's like, well, that'll just disengage at this RPM no matter what, and then it's always at this given gear ratio no matter what for the supercharger part when it goes down to a lower RPM, right? So then it turns further into that the turbo part, the turbine part, can be a better designed turbine that's a little bit wider, a little bit longer to capture more efficiently that given exhaust, which now is lower down, which now is further off to the side, which now has given you a balancing aspect to reducing flywheel weight and removing parasitic loss with the nitrogen filter, forcing in more nitrogen, and you can run it at a much higher RPM. That turbo part, making it more efficient, then becomes beneficial, because you can also, once you get to that point, dump it in to your crankshaft after going through other removals of parasitic loss, which means you can be at a higher RPM, more balanced, and ultimately have less parasitic loss. This is what I'm really talking about. Like, I don't think people really understand parasitic loss for that flywheel as a weight, or the, the friction component as like, oh, well, I have to work against a crankshaft that has a vacuum pulled in it. Or it's just like, now it's vacuum here crankshaft, vacuum here head and bottom, sure, but then also, no, I have exhaust or I have the nitrogen filling it up. And then I get that power back from that nitrogen, either as reduction of back pressure or straight up as power transferred during power stroke. So power stroke transferred into turbo, and then power stroke transferred into crankshaft. You know what I mean? Which is going to be captured and used for air injectors. So like the air injector stuff, super simple, kind of stuff. But that's all for like Formula One, right? But I wanted to talk about it for like, well, I imagine myself getting like a basic kind of, inline four engine vehicle, right? And so I was thinking about how best to utilize a cold air intake to an inline four standard, cross plane, trying to balance, crankshaft, which like normally they do parallel or something, but it's a cross plane balanced inline four, right? So it's like, right, it'd be 1, 3, 2, 4, or like that in terms of its firing order. So I first started off with a manifold that I've talked about previously in my YouTube channel several times actually, but I've been slowly reiterating it more and more, refining and getting it better and better and better. So the first concept starts like this. I have a basic like set of velocity stacks, right? So it's like they're in line, they're just like a parabolic funnel. That's all it is to where the ports are. And then I have a existing housing, which is the manifold, right? Right? But it's like, then it's just a throttle body and a cold air intake, right? Right, like there's not much there. So I can't really do much, right, is what I thought. But like that alone would improve performance by about 10 horsepower on average, is what most people tend to be able to get from a setup like that. Even with a larger individual throttle body and a slightly larger, filter and intake area, right? Like that's what that would be. But then it turned into something different very rapidly. I was like, well, what's the problem with how these work? And so very quickly that changed into, there's a intake at the front, and now I have an intake coming up at the rear, but at the bottom. So I split it. I have the manifold be like a certain size of given, consistent diameter, and then like the intake at the front is pretty much the same size, and then it widens to a slight difference of internal diameter, but then like the bottom, because it has to go along the bottom to look reasonable and not weird. And then it's like, and then it just did basically a 90-degree turn, then a 90-degree turn. Not super efficient, but it worked, right? Like I did get more volumetric efficiency. And I was like, all right, I'm gonna fucking play around with this. I first started with like, I'm gonna just make the inside diameter and all that, and it's like I was getting practically nowhere, right? Then I started looking into fluid dynamics and thermodynamics and a whole bunch of other stuff. So it's like golf balls, bird feathers, airplanes, ram airs, scramjets, rocket engines, nozzles, NASA, anywhere and everywhere I could find any goddamn little tiny trick that they've learned. Like literally, I was just like, what have I learned in my memories? I've seen many things, let me see. So I was like, alright, I'm going to go do that. And so then it turned into, there's these little channels, meaning curves. And so I'm already starting a curve on the outside, or the bottom part where the back, intake is, right? I'm already starting that curve. So it like goes down and it's already starting to curve inwards. And then like these little channels, like little U's. Think like you take your fingers and then you'll look at the in-between space of each knuckle, like you're going to bend your fingers, right, into half, and then you're going to look at the knuckles, and then like there's little areas in between, right? And it's like that's where a bunch of little dimples are along the sides, and that's effectively how I set that like initial transition. So it's like it's already curving on the outside, and then I have a nice little parabolic over, hang that smoothly, so it's like wider, and then it slowly transitions to like the same diameter up at the top. Sort of like your nose, bulbous where the nostrils are, and then it gets to the bridge. Right? Simple stuff. You can understand that. And like where those little fingers are, those are some dimples on the inside, and then right there where the little U part is at the bottom. That's all it is, and it's just going to be a smooth, like, nice little teardrop shape at the bottom, and then it like gets to a finer point at the top. Another version of the same thing. All to help try and really efficiently have it curve from the bottom to where it is, where number 4 intake is. Okay? And same thing for the front. Effectively, I just kind of left it alone a little bit. I just made these little channel grooves that are, for the inside diameter, basically just some teardrop shapes, stators. Okay, which, that's all I did. That's it. They then slowly transition from like this, outcropping teardrop that's a hemisphere-ish kind of shape down to being completely flat and smooth to the surface of the inside diameter of the intake manifold. It's like, we're not done yet. So as you look at the top of the manifold, it's like, it's bent wider and then like transitions towards the center between 2 and 3. It parabolically spikes, so another curve, but instead of like a Hershey's Kiss, it's more of a flat. So it's like that, and then remember the channels I talk about? Same type of thing. They start wider, and then they kind of basically stay the same after they get to past the wide point and trail down. And then it flares out at the tip, and then it has those little knuckle, grooves that I talk about, angling off towards 2 and 3. 2 and 3 has these little, we'll start with 1 and 4. So 1 and 4 has these little overhangs. So they're waveguides. They call them waveguides, but they're just overhangs bent at like a 45 that have like these little, wide at the base and then go to a single, like a triangle tip, but then are angled and bent inwards, with the very tip being actually flared upwards and flattened. So it goes bent at the tip where at the base is, and then it flattens and then it angles up at the tip while curving inwards with these other little grooves that I cut into that where that tip is, and it's round. It has to be round. All of those are angled towards 2 and 3. And then on the other side, more of those grooves of the other side of 1 and 4. So it's like towards 2 and 3 from 1 and 4. Those are where the overhangs are. And then on the closer side of the in the middle, that's where those grooves are and those little dimples are carved in. And then there's a halfway point, of course, that no longer can do that, and it's all meant to help transition these air pressures back towards the center, right? So when it goes 1 and then 3, and 3 can have now air pressure from 1 and the intake from where 4 is to get that air coming in, right? So, but I'll be brief on that because it's like, it worked, and it got more horsepower and faster air velocity and more air pressure as a result, so better volumetric efficiencies, right? Good stuff. And that little teardrop thing and then like little groove for the funnel, for the velocity stack, still exists, still works, still transitions very efficiently as it'll go over, right? But then like 2 and 3 is another version where it'll go and angle itself towards 1 and 4 on the inside and the very middle outwards, right? Same thing, but again, it's the same shape and size. I didn't really change any of the waveguides, and same thing with the grooves on the other side opposite towards 1 and 4. The top, however, is a little different, as like, remember that little angle at 1 and 4, and then it goes to that? It's like kind of a similar thing. There's a little bit of like these little wave bumps. They're just undulations at the top. Okay, so it's like a wider and then a much smaller, right in the middle of each of where, so like in between 1 and 2 and 4 and 3, like that's the longer one, right? And so it's mostly not like going to be seen much, but it's capturing some of that, you know, pressurized air and trying to bounce it back towards that center, right? But then in the very middle of where 2 and 3 are, there's this shorter one that's now there, that's a little bit further out, that then tries to help with air pressure curve in towards that, but then as it goes up, it'll try and push it back down towards the center for where it tries to bifurcate it towards the center where that little top part is, and then out towards where 2 and 3 are, right? But then the rest of it then goes off towards where 1 and 4 are, right? And it's like, that alone got me 17 more horsepower. Like that. All told, from a 10 to a nearly double increase. Now there's tuning that has to work with that, but that meant I got better pressures and velocities coming into my ports. That's when it's like, well, alright, I got this double flute. So a velocity can be increased, but also help to maintain pressures near the ports. So like, this is the reiteration on that side. So it's like, I got the box as best I could get. You know what I mean? Like, this is the best I can do. This is the guy. This is it. This is all, like, the sides, it's like just meant to help the whole thing curve into where it is. Yeah. You know what I mean? Like, people are like, well, this is the top. What about the sides? It's basically the same thing. I was, like, super tired at that point. So it's just like, it's the same, it's the same little bumps and grooves, the tops, just to try and curve it in. It's it. But they're like mostly angled slightly to try and help curve in that air pressure towards where the intake is. That's really the only thing I did, right? But it's like, all right, but we're not done actually. So it's like the velocity stacks, right? Like they're the same thing, but like now I put a second one, right, around towards that middle, actually slightly further up, but it looks like a little donut. It's a little curved part, right? But it's like, it has to connect to the inner, because I cut that off and I had made it smaller in terms of its diameter than the port, right? And it's basically half. These little stators are angled little stators that are kind of teardrop shaped and then trail off, but then there's a oval shaped hole that, well, when you look down towards it, it looks like a very straight shot of air, effectively, and, you know, like a low density radiator, okay? Like a low fin density radiator, and so when you look through it, it's like, you know, it's almost like it's not there. You can still see there's some in the way, but that's it, right? But then when you look at it on the other side, all of a sudden, it doesn't really look like that. It's like, it's wider, and there's a lot less, right? So it just means that as it goes one direction, it's more like a Tesla valve versus the other direction. So it's lower resistance one direction than it is the other way. But like that other way resistance actually starts working as it'll curve air and create these little, drag zones, lower pressure. Then I also had to go into my ports and create these like little vertical channels. No dimples, no nothing are there, right? There's nothing like that going on, right? But like they're just little flaring out to the edges of where the port is, where I have this connected. And so instead of like wider to smaller or any of that, it's pure straight, and they then just transition to a smooth transition where the ports are. Okay, that's all it is. But they're slightly angled where the stators are connected to the inner flute. All right, all that means it'll start turning things, and the rest of it wants to flow together. So it'll start curving and rotating it up in the upper chamber that is sealed to the inner flute, right? So now that one was super simple to do, honestly, especially when like the inner, like the little long stem for the tail or the flute part is like, it starts off small and then it gets wider, and then like these are where the stators are that are connected to the wider part. There's still like a little like actual gap, or not, well, you know, there's still some material in between, okay? And so what it will do is, as it goes through, it'll start widening and having more actual air pass through where the tip is after it's been accelerated, reducing pressures there, but then also sucks in air from the outer flute. But because it vortexed a lot of it, it then happens to maintain that, and then it gets realigned with the little stator thing, and then gets dragged in and sucked in, as the Bernoulli principle applies with the Venturi effect that's created. So it's lower pressure there, but this is a higher pressure here, and then it sucks in air as it will keep and maintain in a vortex, where that donut is, a higher pressure that's consistently there. It's like, it does not, it won't do any of these things, I don't even know what you're talking about. And I'm like, well, you should go look it up. That's literally how, it's just a vortex inducer, but like, it's easier to capture a damn large amount of that pressure as it will head back up to where the manifold is. Well, a good damn amount actually gets captured into that, and as it continues to go through and use its RPM as an intake air pump to compress with that rebound effect this air, consistently rotating it, it also happens to be an efficiency increaser, yes, but a compressor now. Right? That's all it's really doing. It's like, well, it's a smaller chamber here to here, and so like it now wants to go to this area more easily, and it's already, you know, moving in a vortex fashion, so of course I'll just continue doing that. And there's lower pressure because as it spins faster, it sees it as a lower and lower pressure. So effectively, anyone that says it wouldn't work, you're wrong. Physics says no, deal with it. It's literally that for me, often. It's like, so you're wrong, the physics principles apply every time, no matter what, even if you don't like something or don't know something, physics still exists. Then it has a phase transition. It's like, well, no, I'm lower pressure in the view of like that rebound, but then I go from a lower pressure to me relative to that rebound to a much higher pressure, right, is what you would assume. No. Much lower pressure as intake comes in, and a higher pressure where it started at, technicality-wise, except not really. It just elongated and evened out its pressure. You know what I mean? Which undergoes a phase change and allows for some of that heat to go outwards for the outer diameter and inwards towards the rushing air, right? Well, there's going to be gas, as in liquid fuel that we're pumping in as a port injection to shut up. Is what I thought. Turns out, no, actually that was a bit real. That was a bit true. Like, honestly, that part was kind of shitty. But when I really got good at it, like, this is all sizing, diameter, lengths, all that, and for the RPM that it's going to actually operate at, I got better and better and better results until I got up to 10 psi. maintained in this little tiny area. But like 10 psi in this little tiny toroidal donut shape doesn't exactly equate to 10 psi as if it were the whole manifold. Okay? So, what I got from, let's say I started at 1 liter, right, of a volume of a single cylinder, well, with the little velocity and then like all those little overhangs, I got up to like 1.5, right? And then I got the double flute, and I got all the way up to like 2, right? So like, that's good. 2. But then it's like, well, actually, it kept getting better and better as you would like actually use it, right? And so it would go from 2 to about 2.5, and not really. Like, it's briefly, and then it's really more like in that 2.2. It's like at most 2, like consistent, and maybe 2.2, and then like a brief 2.5 would occur. You know, like it's real, finagle. I was like focused all up in there on it, and it's like, you know what, screw this. Like, most of my pressure is basically bleeding out. I can hear it where my intake is and where my throttle body. Like, I can hear it do that. So I looked at scram and ramjet technology, right? Like actual jet technology. And so I was like, all right, we're getting a teardrop shape. Screw this. I'm getting it, like I was looking at Tesla valves anyway, so I have these 3 overhangs to where the tail is of this teardrop. I got a big diesel, huge boy, 8-inch fucking diameter bore, like, intake. And it just barely fits in the, I had to get a whole fucking, put a freaking little aluminum and then some caulking and all that and some bolts to like the box that it originally came with, and much bigger box, huge. And then it goes from like that 8-inch to like a much smaller diameter, like 5-inch, really, honestly. And then like that would then go to this little teardrop that would then, separate it into this little, much larger, again, 8-inch area, well, 8-9-inch kind of thing. Anyways, but then that's attached with like teardrop stuff, right, at the actual front, okay? Right? And then it's like, no, actually, I don't really want that to be anything other than just, that's the same equivalent volume size, right? And so like that teardrop shrank. Like, you think it's like the same size. It's not. It's certain gapping, certain, areas, but like as the tail goes in, these are overhangs that never touch the tail. And so they're mostly attached, or they're only attached, really, from one spot where the inner diameter of the tube behind it is. But these overhangs are offset, so like, think there's like those little wave guides that I was talking about, like those little triangles that are curved in and whatnot, and then like in between there's these little teardrop shapes that have the next wave guide that's going close to the inside diameter, but they never touch, and they're get close to the tail, but they never touch, right? Like, these ones are in the very last point where they are connected to the inner diameter of that tube behind it. And so like, that's basically all they do, and they get progressively better at stopping and blocking air pressure going back out. And that's why that's a 5-inch. This is the biggest, meatiest throttle body I could put for that fucking, that 5-inch area. But what it meant was that captured all of its rebound air as it's getting more and more pressure in the manifold, and then it would capture it and then redirect it in as inward flow would happen too from the throttle body area. Huge upgrade. Like, I went from like that 2.2, if, and then like a brief maybe 2.5, stuff like that, where now it's consistently 2.5 to 2.6. You know what I mean? Like, not much. You know what I mean? Like, I can get up to 2.8, 2.9, but like, it's mostly 2.5, 2.6, and like, like those brief things, like, I could be pretty consistent at making them occur. And the sound of like all this escaping rebound air, like a turbo flutter almost, you know what I mean? Like, went away. It's completely gone. So it's like, yes, I've captured like everything I can capture, really, right? Is what I thought. I realized it's like, well, I have this ability to make this work better for me. Like, I'm not doing the right thing. I have a 1 3 2 4 1 3 2 4 1 3 2 4. So then I had a so I cut the outer flute a little bit. I placed on this wide to smaller diameter, and I have it curve inward to 3. So from 1 to 3, I have another flute from the secondary flute, right? And then I have a valve, right, that basically blocks the vast majority of that air going outwards. And in fact, it's kind of like an angled poppet valve, except I have a rail there, right? By this point, I was getting up to that point where those fuel injectors were starting to become something I could really use. So I'll get to that part. This is the fuel injector tech that I talked about, or I haven't talked about, but I will talk about. It's a good way to put that instead. So it's like I have this rail, it's just hydraulic fluid, and it's got some heatsink fins around it, but it's chambered, and I have to, so it's a hydraulic ram with a spring on the other side, just like regular valve. But the reason why I did that is because I didn't want a super long stem. I wanted to find something that I could actually use that was readily available and wouldn't get in the way of where I had it, right? That kind of thing. So what that means is like that poppet valve is basically not seen. And then it's suddenly there. But that's a, you know, it's a way it's angled in. Like legitimate, it's an angled in, but then it's like, all of a sudden, I'm here. Nope, I'm not here. All of a sudden, I'm here. No, I'm not here. You know what I mean? Like, it's like this is pretty angled over here, but then it's like, oh, I'm actually, you know, but anyways, think it's like your elbow, and then like as you move that, and then think your hand. And so like if you're thinking about like a flute, like you have to angle it the correct way, so that way you can pop up and do that kind of a situation. But I don't want it in any way to get into anything and have a seat that it can stay in. So that means it can't do what you want it to do. It has to be angled the right way and not have the stem really be something you care about, really. You know, because it's like, no, it's going to seat right there. It might not look like it, but it will. Because like we're going to have all that air, even though some of that air is going to escape a little bit around, it's mostly seated, right? So anyways, the hydraulic fuel, it's a rail, so it's just a hydraulic fluid rail. I'm not pumping any extra pressure, nothing like that. It's supposed to act like a push rod, except now it's less weight, and there's an area, because of the chambers I'm talking about, that it'll push this fluid, because it's a vacuum, and so it'll push fluid over to here, and then the vacuum basically sucks it in, and then it opens that, and then it goes right back in much faster with a lower spring rate. And so like, if you don't maybe understand how that works, I don't really feel like explaining it in great detail, but it's a top, bottom, side to side, like kind of like a cross, and then like the bearing has to exist in the middle, and there has to be a diaphragm to make that work, right? And so like I can attach a diaphragm to that all day, and as I push in, it's already going to push in the fluid, which is going to push that in. That creates a vacuum, which then goes off. But it's like, but another area, right, because that's how a hydraulic, right, so it's like, that's technically not really doing that. It's really pushing fluid elsewhere, and then that moves the fluid from where it was and creates a vacuum and a lower pressure flow area, and then a higher pressure, hydraulic fluid in that area to there instead, and then as it goes back with the spring, it'll just go back to where it once was. You know what I mean? So it's effectively just a diaphragm sort of setup, but that means it will also undergo a phase kind of transition, kind of like a pulse tube cooler, and that's why I have the heat sinks there, so that way it never gets too hot, and it's way lower weight, and I can have a much smaller spring and a much smaller stem right? Which means it's much easier to do what I want to do. So from one, it'd be a little higher up, but then it would curve from up at the top towards lower down where the actual ports are, and then dump off at the sides into three, and the secondary with the rotation that I have there, secondary flute, and then three would be another version. Because remember, like, even though I'm creating a like sort of short and long runner situation, I have a short runner where the intake is at one in the manifold area, and then same thing with four. Is a short there, right? And that's going to have a long from two, right? And then three, from two is a short, but then they both have, for two and three, like medium to slightly longer long runners, right? So that's essentially what I was doing. So one into three, and then three would be like effectively from bottom up and then curves down, sort of a thing, just like a straight sort of in the center, right? And so like that would then dump in with the correct spin and everything, and it helps with the valve, and that's a side. So as the camshaft would rotate, it would then close the intake valve and start opening this movement, air pressure relief valve effectively. So it's like it would hit this valve right after, and then move this like that, and then have that given duration, and it would return. Okay, yeah. So that would curve into two. Two would then go from the bottom near the top, and then curve from the top instead of at the bottom, like at one, downwards to four, right? And then enter to the second flute. Four has at the top, this is why we curved it at the bottom where the ports are, situation to three. So four goes towards the top, it goes through two and one, and then dumps into the flow where one is. And from like 2.8, it's pretty consistent, but like not often, right, to 3.8, like consistently, all the time. 3.8 liter, like consistently, it could jump up to about that 4.2, but consistent 3.8. And from heat that I had to worry about to almost no heat, it just didn't matter, because it would basically cool itself off with its own version of a air-to-air intercooler going on. And then this is where I had to get into, because I was now fuel limited, right? So I was like, well, I have this, I could buy a fuel, fuck this, I already have a fuel pump. So it's like, I'm going to run it at a higher voltage. It's not rated for this, really, but like, it can do this, right? It's able to run at this voltage, at a higher voltage. And then I have a spike voltage sine wave that it would run at as a pulse every so often with a capacitor and the right circuits. So I'd pulse it to a higher voltage and have it spin. So it's already spinning faster, and it was zoo, 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 all the time, right? That's what its main operation now always looks like. Fuel pressure rail system, because I have the same injectors, it's the same. It was like at a much higher pressure, but I bored that rail out, and so it has a larger inner diameter, and then I basically sort of put another thing around it, clamped it down, and then put some areas where there previously was a little bit of this kind of like heatsink fin. That's where I put a bunch of braze rods, and then I had this as a sort of bent sheet, right? But it's like a thicker sheet gauge, and then I just dremeled lines into it. And so like I got back my heatsink fins, but it's a thicker, so I bored it out, but it would have been way too thin to survive that pressure, but now it's fine, right? But it's like, then I have larger tubes, genuinely, yeah, I found a word that I could use. It's good enough, It's So effectively, yeah, no, I just found larger tubes for fuel, but they're metal. I had just replaced that from where they were. Same pump though, so like they come in, and are able to handle higher pressures and different fuels, right? Same injectors. I never changed injectors. What I did though, however, do was I drilled out a few thous, and I was looking at it for like where they're gonna intake or that kind of thing. Yeah, it's like, well, I have a different O-ring. I want it to compress around that really, really hard, and I looked at like what that would do for changing diameter sizes, and so it's like, bored it out a little bit more, another few thou, and then it's a bigger O-ring, but then it's going to compress into that, and so like now I got even larger intake for the injectors I originally had. I had to clean them all off, all that. Yeah, I didn't change the nozzle size, diameter of anything with that injector, but now I was able to pump with the timing changes. So with a fuel or a pressure gauge, all right, that I had, and an RPM, crankshaft sensor, right, it would change dynamically air fuel map setup. Yeah, but it's like I couldn't start that way. So like before I even got to that point, this is how I managed to make my injector time and everything work. I started off with a bunch of data points I made, and I had an Excel spreadsheet later, and then I used that from there. So it's like at first I had a 4-cylinder, and I would take out one of the cylinders. I wouldn't have the spark plug. Instead I would have a compressor sensor, and so compression sensor, right? Air pressure, all that. I wanted to know with temperature as well. So I had temperature sensing and all that set up for all of that. And then I went from 4 to 3, 3 to 2, 2 to 1, and I would have to like go through my rev range and at different like slopes and areas of heat and temperature, and that would calculate for the expected loss, because that flywheel and all this, it's like it's expecting a given pressure during power stroke to also help with the intake cycle. This is before we got to the valve tech. This is before we got to the runners. Before we got to anything. Any of that didn't exist. You know what I mean? Like all we have is the double flute, and that's it. Because it was like, well, I'm getting more now. Like I need to be able to do that. Like we didn't have the ram air, or not the ram air, but like the little teardrop. Like pressure helper, whatever it was called. I suppose it's like its own version of a passive valve, like a Tesla valve, but it's a Lemke valve because it's a teardrop with little overhangs. So I was like, whatever. Which, FYI, just for anyone out there, with the bottomer thing that I was talking about and how I cool the piston rod and still keep it lubricated and everything, and then like the nitrogen injection and how I have the crankcase vent and all that, it's a Lemke cycle with the offset in the elbow. That would no longer be an Atkins or Brayton or any of that, because it would be combining several, and so it's now a Lemke cycle engine. So moving on, I had that, and it's like, well, I had that expected loss, so then I used timing. So like, remember I was talking about how, well, I hadn't recorded that, so I was talking earlier, and you wouldn't know unless you were hacking me. So moving on, I started injecting before the intake cycle happened, which meant I was pouring fuel into the port area to actually get enough fuel in, and then having a specific duration after intake and pulse amount after intake to ultimately have enough fuel to make it work. Well, I was like, well, it's cooling my ports anyways, because, vaporization and so on, right? Phase change stuff. It's cooling like the donut area, so it's fine, like whatever. But like, I can't have it hang around with too much fuel, right, after intake has stopped. You can't do that, you know what I mean? So it's like, I got enough air in, and I got enough fuel in, and it was making much more power. Like with that alone, I was able to go from that like 17 I was talking about with a little bit of that, then all the way up to 50-ish. Like this is more in that 40 range of just horsepower gain. Then once I got in the little teardrop, it was like, all right, so now this has to change, and so so I had to test a little bit more, change that. I got up to 57. 57 horsepower gain with that larger intake. I didn't do any RAM. It's just a larger and a big throttle body and all the rest of it that I had to do to make that work, right? It's like before it was like, this is a like maybe 2.5-inch throttle. This is now 5. It's a much bigger, big boy throttle body. I had to put the mass airflow sensor somewhere, right? And so like that's the in between the manifold and after the little valve thing I've got going on, right? You know, so it's like that has to happen. So that's right there, smack dab in the center. But like I also have to teardrop it. I put like a nice little, you know, aluminum teardrop, like a little bend and all that, so that way, like, oh, you know, it's got perfect sensor, but I don't want it to disrupt any of my airflow. But I want it to curve it in just a little, you know, because like that's, you know, and so it's like I'm gonna help that with the aerodynamic efficiency as best I can. And so all of it comes in really smooth, great, easy transition, stuff like that, right? You know, and then it's like, but no, but wait, there are things called ram errors. I was not ram erroring at all. Let me get that done. And so like, you know, with the box. And I had a big long pipe. It was already going where the cold air is at the bottom, off to the side, right, where the car is, you know, where the front end is. And so it's like, well, now it goes all the way over here, and this is a bigger area, and this is bigger to a tapering smaller, and then I'm just gonna tuck it right there, big huge snorkel thing. So it's like, this is now my ram air thing that fires itself right all up in there to where the intake box is, and it's like click, 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 all these torques. Because it's like, no, if it gets pressurized there, it needs to be able to handle the pressure and not ultimately cause issues. And then I had to put another teardrop valve thing, so that way that air pressure doesn't go back out towards the ram air. Because it's passive, and I just didn't care anymore. You know what I mean? It's like, well, you know, that'll mean I don't have to have a bunch of little cables around, and I don't like cables, so fuck it. But it would work better, honestly, for what it's worth. Like as it goes down, you know, on the RPM for the engine, it would just automatically turn that ram air into something that instead of a fully open throttle, it would then slightly leave it open and capture a majority of it. Which, to be fair, I sort of did anyways. Like the passive thing effectively just has the hemisphere go into a little gap system. So it's like, wow, there's a higher pressure here. Dunk. Yeah, okay, fine. It's just a little vacuum thing. It's like, it's going to keep itself floating up, but I just removed the amount of weight because it's pointed downwards off of a little vacuum, you know, spring. So it's like diaphragm, little lower pressure, and then it's just floating, and it'll go down. Like the moment a little bit of air comes in, it's like, oh, you know, and then boom, you know. So that's what I did, and it's like, all right, so now I'm gonna get the ram air. I've got, well, fuck this. I can just put valves. Why don't I just put valves here? That's when the valve thing happened. By that point, I was already doing other stuff with others, you know, intake and all this other sort of ideas. I was like, you know what I mean? I took the heads off. I'm like, all right, so I'm gonna pour and polish finally, right? I only got because it's a 2 valve system, but they're angled. You know, it's supposed to be performance or whatever, right? But they're angled valves, and I'm like, big ass wide channels, a little dimple right there, and then like the little overhangs that I carve in from inside to make sure that as like that capture of that, you know, just a little bit, and forces it to be much more conducive to capturing that pressure. So it's like, I'm putting valves there anyways. I have to drill into the valve cover. I have to do all these journal things. Screw it. I'm done. Right? Like, I'm doing the whole thing. I'm doing it all up. I'm doing all the fucking things doing and done. Yeah, I'm getting them all done. I'm fucking done with this. Right? And so exhaust got another version of overhang kind of system, and it's wider here and it's slightly smaller, but it's more just straight, easier curved flow. You know, then it's slightly going to flare out with these little overhang, you know, grooves I carve in with these little straight lines that run through it, where the exit part is for the exhaust ports. And then it's like, these are now going to be, you know, here's a roller. These fuckers. Who made this? Who made this exhaust manifold? Getting out the Dremel. Just fucking carving in shit. And it's like, well, it needs to go somewhere else, right? And so it's like, right, now I'm just gonna fucking stick this over there, and then, you know, high temperature silicone caulking, and, you know, bolt it down. I'm not kidding. That's legitimately with some brazing I did. And then I was like, you know, cut it off the side, and then like little grooves and channels again. But it's like that manifold turned into like a much larger inside diameter manifold that happened to also take that pressure, just kind of like with the intake, and then send it off towards where there's already a vacuum area. So meaning like it already exhausted, and then it pushed itself through, and there's like a bunch of little thicker aluminum bends, you know, and then I had to weld and all that stuff. But it's another version of the same for the intake, where it's like, I'm going to dump it over to here and here, and then I already have valves, I'm already doing all screw it, and then I have valves, and then instead of any donut things, it's just meant to dump all of its exhaust into all the other areas with like this little valve to basically both dump it off to that area, but then also close where the vacuum would ultimately be from that given area. So it goes from that, and it's like, now it's got a valve here. And so it closes off these, dumps it off into all these other places, and then that tries to, during that, have it all send to a central point now instead. Not a joke. It's like, normally it comes out here, plugged up over here where that is, and instead like 1 and 4 goes towards center, 2 and 3 goes towards the like an intake and exhaust area, and so like it all heads towards the center, and then it uses like the little valve things to help move them effectively towards that situation, where it also has to go through, like 1 would go to 2 and 4 because it's not firing, and then 3 would go to 1 and 4 because it's not firing, and then 2 would be at 3 and 1, and you know what I mean, like that kind of thing. But it's like, you know, that's fucking annoying. So it's like, whichever you know, like the next nearest is literally what I started just getting pissed off about. But then it's like, no, then I'm going to spread it over here and here and here, and done. The trifurcation complete, center, this area, right? As we go through, and then off to the center, and then off to number 3, and so like, whoosh, and then try and all direct itself towards this bigger one single. I didn't think it'd survive. It's steel, for what it's worth. It is steel, then coated with some high temperature silicone and some ceramic powder coating, and I baked it. And then like that's like all of those into that one little valve, which is another version of just like it then goes inwards with the cap, and then like it then closes once there's a vacuum thing, which it's like got this little overhang, it's a hollow tail, right? But then it's like got this little overhang area for like any back pressure that tries to come back in, and then these hinges on the tail where it's like, because it's flat, so it's like it starts off curved and then it gets flat where the tail is, and the little overhangs, and then it has the hinge, and so the hinge then goes downwards, completes the tail section, and then once enough air pressure has been lost, it then happens to flare up, and then for the center hollow part where the tail is, that then closes off the valve that's on the inside, because of course it has to tilt like that, right? So it's like it's gonna open, and then as that air a little bit, that exhaust is a little bit going to go into that pushes forward the little, it's got a little bit of a vacuum spring, okay, just to make sure it's very much like free floating, but it's effectively just gapping. Alright, so like that hemisphere for the teardrop means it'll just go forward because there's a vacuum in front, right? And so like it moves a lot, but it's just a little bit of a gap, and then it goes into a much wider body area. And so like it sees like this size diameter, and then because it has to go around, it actually goes into a same size diameter volume area and skips over just a little bit faster, and then it dumps itself out into like, here's my tube for my exhaust. Well, it was originally here, now it's here. And down it goes. All natural aspiration, by the way, except for the fact I have a ram air now. Yeah. And so that one I never dynoed. I was doing other things. I was like, go all the way. Yeah, and then it's just like, well, it fucking certainly picks up. Given like how I have already seen for my dyno for the given air pressure and the RPM and the expected loss and all that I tested for, I am going to set up my air fuel mapping this way because it should work that way, right? And it felt better. I'm not sure how much more over 57. I would put it in that 25, extra horsepower for what it's worth, like 75, because it's essentially like I'm going from a 2.5 to 3.8 for sure. And so, but then there's inefficiencies, and then I'm like, well, I'm going to try my best to get rid of that, right? You got a crankcase, or like the header vent, for the valve cover vent, right? Right, and then it's like, then I also did exhaust stuff, and I ported it, and so it's probably better. It's, in that 25 horsepower extra, range, I'm putting more fuel in it. I got the timings for like injecting enough fuel ahead of time before the valve opens. So even though there's maybe more pressure, I'm cooling it off with the gas, and then it's very good flow in and air fuel mixing as it goes through that cycle. So yeah, no, I know, yeah. You should take it to get dynoed. I never did. I was off doing other things. I have no idea what that would really be, but I would for sure solidly place in a conservative way at that 75. My guess is I'd probably get closer to a 90, so if not in the 90s for an extra horsepower gain just from like just super trick intake and exhaust system. It's like I turned like a standard manifold into like a small little equal link tube header setup with some valves and like parts that I had to bolt and then high temperature silicone caulking it together, all just so that way I could get it to be more efficient outright with like really trick porting, you know what I mean? Yeah, it's like no, go into these little grooves and it'll already start its transition inwards, and then be really smoothly transition to like the valve area, and then I'm already trying to get it to start curving like that, and so I'm going to have a little bit of a vortex induced here, and then it's going to start trying to curve along with the intake cycle, and I have a little bit of scavenging that already exists because they set it up for that, and I never played around with it, so I was like, right, well, and you know what I mean? Like, what's with this scavenge problem? And it's like, well, you know. No, okay, so scavenging means that my fuel's going somewhere, right? Out. It's going out my exhaust. So it's like, well, that explains a lot. Yeah. For what it was worth. And so I knew about the problem. But it's like, for me, that means your injector where your other valve is, you're already pouring in. No, I can't do that. Remember, like, I can pour in fuel for the runner in to the next intake. And so it'll take its time getting through the 1 to 3, right? But, like, during that scavenge, it'll evacuate its exhaust and some of the intake, but then I'll also have fuel rush in to be able to make that occur. So I should have been more clear about that, but, like, I knew about the problem already, and I was trying to get around that problem regardless because of that damn, like, fuel, you know, all that injector thing. And so I was like, when I said I'm fuel limited, I meant I'm fuel limited because I can't get around a certain amount of fuel being pushed in, because advancing that timing and duration doesn't mean jack shit after a point, right? It's like, I've got a scavenge effect, and I'm like, yeah, I don't care, I'm not being able to pass my emissions here. Fuck that shit. I need to be able to pass my emissions. You know, so, yeah. And that's where the whole idea of having that, like, runner go to another firing order area with the valve thing. I was like, I'm sick and tired of not having enough fuel. Well, you know, what if I had... Oh. What if I could fire it into the thing, and that would go over to the other side? You know, for the next... That would be so much better. Right? And it's like, no, you don't, no, what? It's like, no, definitely, it works that way. It was like, I have the injector for that set on a different timing than the injector for where the... Well, it's the same injectors. For what it's worth, it's the same injectors. It's just different timing stuff, and it's different distance stuff. So it's like, well, technicality-wise, yes, as it goes through, it's given like 3 to 2. Like, I can dump it into the little donut outside flute, right? But in 1 to 3, I have to have it in the inside of the flute, that are like the other runner from like one side to the other. And then 2 to 4 is another version of like 1 to 3. 4, so like there's very specific areas I have to have it at for this to ever work. And it's like, no, you'll always have a certain amount of fuel in that. And it's like, very specific areas for this to work. And angles, not even a joke. It's like, remember that 1 to 3? Yeah, I basically spray it practically into the fluid itself. But it's like, no, but you kind of, no, it's this amount of air that will go through first, and then this timing advance will then mean I can get that, and like that valve is going to close, but I can still spray in air, spray in fuel, but it's basically into the damn thing to begin with. Which, like, I know, it makes no sense to most people. It's not, for what it's worth, like, to anyone, it wouldn't make sense to do it. If it hadn't been for the way I'm setting this thing up, it just doesn't make sense. You know what I mean? Like, you would never do this. Why would you do that? Because it's the only way to do it. It's literally like, this is all I've got now. This is what I can do. No, okay, so like, Where 1 to 3, like 1 already has its own like going in, right? So like that's a standard sort of thing, except for like from 4 to 1 is really what that means. But it's like that's where that would be anyways, more or less. Except it's not! It's on the runner! Yeah, no, it's very rough. I'll be really honest. Like again, that amount of air mostly comes in from the donut, but also the intake from the manifold. So like most of the air comes in from that. Then the rest of it turns into like I can pull up because it's gonna fire into that area anyways to a degree, right? But it's like if I delay in advance in this very very specific, yeah, it's like and it's like no, I can now pull it up over here because it's gonna have that air from that with that extra fuel, and then it'll effectively run that fuel, and so it'll take that air now as it goes in for 3, and then I can fire in at that point, and then it's like that's delay, right? It's delay, true, yeah. Like I call it advancement because it's like this fuel goes over to this 3, so 1's fuel goes over to 3's fuel, and then like air rushes in anyways after that, and then I can add in just a little bit, and then during that, and then it's like then that closes in a little bit of after delay, you know, and then that's advancement for 2. Then 2 has its own like, well, it's going to take mostly from this, and then like this is. And so, like, there's a little bit from 3 to 2, but most of it's from 2 itself. And then it goes, scavenge, and then it's like, right, and then 2 gets 2's fuel, and then 2 helps with 4. 4's fuel is coming from both 2 and 4. So there's an overlap there. Yeah. It's like, and it's like, oh yeah, no, scavenge fine now for 2 and 3 and 1 because 4 got more than enough fuel. Finally, yeah, right. But it's like if I didn't do it the way I'm doing it, it wouldn't work in the fucking slightest. Which I call that an advancement of timing, even though it's really delaying timing and then keeping up with timing from another one. So I'm delaying it here, and then I'm advancing it from over here, but it's delayed or continued from here, which helps with that whole system. So it's like, but it worked. It worked pretty darn well, you know, like there's a little bit of residual fuel sometimes. A little, yeah. It's mostly during like from like I'm at like the high top end, and then I went boom, right? It's like I gotta slow down. And it's like there's a little bit, and then you know it notices the pressure drop, and it goes no, back off that. Yeah, so it's like there's a brief moment where there's slightly more fuel, like very brief. We're talking a couple milliseconds. Like it's really from 1 to 3, and that's the only time it really kind of technically has that. Does that mean it has extra fuel in there? It doesn't see it like that for the scavenge, but it will for its intake. Yeah. Yeah, so but then that means like 3's injector just doesn't do that. So it's like no, I haven't, and then it knows, and then it goes like no. And so it's like got the right amount of fuel, but it would have had extra fuel if I hadn't done that type of timing setup and change for a dynamic fuel map, air fuel map sensor stuff. Yeah. It feels phenomenal. It's a rear-wheel drive. If you want to know, it's an inline 4 for Miata. I got a Miata. I got a Miata. It's like genuinely, it's an old Miata. I eventually fucking got all of this stuck together the way I did it. I got actual, real-world benefits from what I'm doing. You know, and so I never really tested that for what it's worth, you know. Yeah, I know, right? Because you already set it up, and it was like, well, with all of this and you know, Excel spreadsheet shit, it's like I'm just gonna try and wing it, just a smidge, right? And then it would eventually go to like a dyno. If you want to know, like I hadn't really ever like looked deep into that future thing, but it was about that 92, 98 horsepower depending on the temperature of the day and like overall where the dyno was for like altitude. Yeah, especially when it's like, well, okay, so we'll take it like normal. It's not in a windmill or anything, or a wind tunnel, right? Right. But then it's like, I'm gonna just, fire in, and then this is just gonna take a little bit of it, and then that's just gonna help out with the ram air. It's gonna be, let's see here, this is the wind speed. It's about this. It's, okay, all right, yeah. And so it's like at different air velocities, which is something that the last dyno guy was like, that's cool. I want to do that. And I was like, you should, yeah, go for it. Right? Yeah. So, anyways, but, yeah, no, I just made like a funnel for that. And it worked really well. So I got like dynamic air speeds as if I was at certain miles per hour, right? Velocities in the vehicle, right? So it's like I tuned it dynamically in terms of like how I would match that with the throttle response, which that one was like, okay, so this is this delay and this is advance, and so this given amount of pressure helps with this given throttle or like movement of a valve that helps with like dynamically altering the funnel producing up to about 100 miles an hour wind with these other fans that would turn on. Yeah, I brought my own fans. It was pretty cool. Yeah. Woohoo! Really? You didn't get to 100, like plus 100? No, that's a lot harder than you think. It's only tuned to 100 miles an hour in a windmill. Yeah, but then, like, that's like different pulls, like, for what it's worth, right? It's like, yeah, yeah, right, yeah, different gears. Literally that, yeah, I had to do all of that, then, like, dyno people are like, super, what? But I was like, dude, it's okay, like, it's just different gears, I'm just going to try and make that work, right, for what it's going to try and see. I'm not trying to step on any toes. If you don't want us to do it, we won't do it. And then I got more fans. As he said, we'll do it. Yeah, no, I know, but it's like, actually that makes sense because he has a ram air and he has to tune it for like all of that. And they let me do it, which was great. And I got all the way up to about 150. That was a secondary session, by the way. Yeah. Right, 150. Well, more like 210. But I don't think we'd ever see a 210 mile an hour Miata. But it's tuned to 210. But like 150 for sure is like a likely I could maybe get there. And I was like, yes, you guys fucking rock! Pimped him out on the old YouTube and all that, doing that fucking fun stuff. It was fun to just like drop it. I had to get a sensor for gear, like gear, like it's in this gear sensor for like the fuel air map, right? Seriously? Yeah. Like that was the second I was like, well, it won't know to tune it like this and use this one. Like, I already have a dynamic alone. Like, so it's like I need this gearing at this RPM at this given, like, speed for the speedometer. Like, all of that to tune everything as consistently as I could. And so it was like, all right, before we even go to because like it's going to take me a while to even get the money and get the time to have the dyno run and all of it. And I've carved out this amount of time. So it's like, we're going to basically, and I was like, do you have more time around this time? And they were like, yeah. Okay, so then we'll do a little bit more time on the dyno to really try and get all of the different gears, the different runs from this to that, to, like expected, gears at different speeds that make sense for it at the different RPMs depending on whether or not I'm on a regular road or on a track or trying to drag race. So it's like I got all of that tuned to 210 miles an hour. Except like, you know, the first gear's never did that, so you know it's like really that's the longest gear. And again, it's like maybe it could possibly down a hill or something, you know. Like it's really genuinely never gonna be able to do it. Even if it's like, what's the governor on this? Fuck this. Pour in the fuel. Screw this. We're gonna fucking make it whatever the hell highest RPM it could really do. What was that? Yeah. Well, we got it up to about 160. It's about 159 something, 158 something. Like we did a couple of pull runs at those higher speed air in of the vehicle, right? So like 160 horsepower roughly was what we were able to get from the manifold alone with the ram air and all that. Yeah, oh, you know, the radiator was not liking that. I'll tell you that much. For what it's worth, yeah. No, it's a stock Miata. I just fucking slapped on upgrades to ports and its intake. It was like, yeah, with the fuel and all that, but it's like, it's very obviously not gonna like it. You know what I mean? So it turned into, well, this is an old ass secondary. Yeah, it's like, look, what's your Miata over there doing? This is my radiator now. Right? Like literally, yeah, and I'm gonna get out the aluminum sheet, and then I'm gonna drill some holes, and it's a nice little box, and then here's my fans in between. No turbos, no nothing, didn't do any of that. But now I've got the cooling, because it's like, no, that's overheating for sure. Yeah, you're right, I should go do that. And I never really experienced any overheating, because I never really took it to like anywhere near that extreme, except for on tracks. So, like, for what it's worth, it would just thermocouple. So it would thermocouple on the off, like, the first radiator. So, like, when it would go out from the first radiator, the thermocouple would then divert that to being two, so as a parallel instead of a series. It'd use both at once and then push it together into the rear. That was the only other modification I did. It was like, oh yeah, no, it goes out from here and then it goes into the rear for the engine to be good and nice and cold. That's besides like the crankcase equalizer pressure thing that I did. So it's like, this is another version of like, as the air is coming in, right, that's another version of like, we're just going to use air going around to reduce and become like lower pressure with the exhaust, like constantly having that hot area, like, you know, produce a lower density, right? And so like air is coming around and that's a lower density, and then that like basically constantly makes air want to travel that way from where it's, you know, smaller and then wider and then much, you know, that kind of thing. And so then that with a little diaphragm and a little bit of a valve, it's like, oh, well, this works. You know, like, here's my header, you know, vent, so like I need a crankcase vent, so like this makes total sense, right? It's like, oh yeah, no, I'll just pump out the air pressure, but then it's like, no, I'm going to pump it in during, that's where the only, like, who the fuck would think about that, like, I got ever from someone. I'm like, it was like, no, during this, you know, power, it's like it should give it, you know, like this, its own version, and it's like, no, it's separated. So I basically made like these little chamber areas, like a two-stroke would have. Remember, like immediately the idea of like, is it a bottomer now? And it's like, there's no bottomer actually. I wish it was though. Right, yeah, except it's like sealed on the side, so it's like girdle effectively, but it's like sealed up to where the actual block is. But like then it's not sealed where the actual crank is going to go through it, right? And it still has oil drain, so like that's another version of where the pressure, but then like that pressure then actually just helps with the little tube thing. So it's like, right, so this girdle then has this crank, right, like go through it, but then it's like I'm sucking out air during its pressure power stroke, and then this then pushes in air during its compression stroke. So it's like boom, and it's compression or exhaust. So it's like exhaust and compression gets air there, and then that then gets sucked out alongside of the air coming out of like around the compression rings during power and intake. Well, except like it doesn't, because it's, you know, during intake it's really just going down. Yeah, actually I wanted the vacuum there, just, like, doesn't everyone, right, during intake? So it's like vacuum, and it's like, yeah, no, well, now it's changing, it's given, yeah, sizing, and like that's just a, all right, so this, I'll just use sliding valves. This is stupid. Like, I'm just gonna use sliding valves. Yeah, and that's where the valve thing is. Literally that. Yeah, it's like this is intake for during it's vacuum during a compression, and then everything else is effectively vacuum, more or less, kind of. So it's like it's gonna have a vacuum over here. Oh yeah, but you said that, but I don't think you know what you meant. So it's like one from that like power stroke, right? It's like, right, but I don't want air to be there, right? So that's going to be forced out, but it's already has a vacuum elsewhere for that tube, right? Right, and then, well, that can also be used during the, was it the intake thing? Yeah. So it's like intake, and then it's like, right, but during compression, right, compression. So it's like that would force that air into where a compression zone is starting to happen, and then that would then, with the remainder, get sucked out, and then a little bit of that air would be during that compression. So it's like really just trying to balance pressures for in the crank. That's all I'm doing. So it's like from like power stroke, it's then going to push that into compression, but then it's not actually as much as you would imagine. It's just really fast, right? And so if I try and have that divert around, it would then go upwards, and usually it's going to be lost to the rest of the crank, and so the crank would just constantly be having air removed, because like there's still gaps, and there's no like super tight tolerances or fully sealed anything, and I need to push oil into my crank and like I need oil. So oil is just like, these are oil squirter holes effectively. Just fire it in. And so everything is really more just a crankcase vent, but then moving the air where it needs to go, and then having everything like work very well that way. Did you remove like any actual horsepower, or no, I gained like maybe a couple, like honestly, yeah, like maybe 10 at most, if that, I never tested. Again, it's like, well, this is done. Like, you know what I mean? I was like, I want to move to a different engine and other things and stuff. And then, yeah, right? So I ended up just trying to do that instead. Selling me on it? Yeah, well, it was given to the daughter I had at the time. She had fun working on it with her dad and her moms and her other sisters with me on it. So it was pretty fun. It was a nice little project. Let's see. It was fun. I had fun. Things were fun. For what's worth, things were fun. How fun. Super, super fun. Why? So I went from like, maybe 160 horsepower to, with an intake manifold and some testing, and all that changed, to like over 207 horsepowers, right? And then it's like, right, then I added 40 more, basically.
So that 240 from a naturally aspirated engine. And a little 2-liter it is. Right? And then it's like, maybe, right? I'm like getting something from that. And so I'll give myself like at least 5, right? Have it, right? And now that's like 245 horsies. Great low end torque, right? Sounds different. Oh boy, does it. You didn't change anything with the exhaust, did you? Not well. No, I did a little. I didn't think it was very relevant. Besides, like the tube, like the manifold, right? The exhaust manifold. Like outside of the exhaust manifold, I didn't think it'd be very relevant to talk about what I did to that. But like, it's a version of like they have like a muffler and like all that, and so it's like I just sort of combined that with some tubes over to where the muffler was for its intake area, and slightly altered where and how that like the exhaust, intake like flared out and was bent and sort of stuff like that, like little tiny touches to improve aerodynamic efficiency, as like there's already a pulse from that tip kind of coming in, but then except it just sort of resonates now, right? And so like then it goes and turns it from like I'm much higher pitch to a much lower pitch, instead of being also a 4-to-1 as it is, because it's a 4-to-1 with a fucking valve, which, yeah, it does basically make it so that way it like captures that pulse back inwards, right? So it actually improved the efficiency of the catalytic converter. It kept most of the heat right where it needed to be. Super fast going right into it. Right, but it's like it sounds way deeper, that kind of thing. But an inline 4, like what can you do with an inline 4? And it's like apparently a lot if you do that. Like, yeah, again, it's another. It starts off wide and then it then goes to a smaller, and it's a whole bunch of those like nice curves and everything in towards where it is. And it's a better structural piece than it was before. I painted it up. It's like, well, it's off. Anyways, so just screw it. Sand it down, get it all bare metal, get out the old, ceramic paint, high temperature ceramic paint, and paint it with some high temperature silicone caulking, and then I got out the little powder coat ceramic. It's like there's a standard like this, like a shake can, and then it's like no, I'll get out the powder coat stuff for the second layer. And then I can't really bake it very easily. Like for real, it's kind of hard. So I just got a bunch of IR and then like some aluminum that I like kind of bent and shaped. And I had like what is effectively a version of some refractory material, heat insulating material, and the aluminum had to be like fairly thick. But yeah, no, it's just point in IR that I heaters that I bought, right? And then it's like it's getting to there, and put in the temperature and all the thing. Well, if I seal this up, this will be way better. So get out the brazing and all the rest of it. Yeah, it's like, alright, so it's sealed for sure. Like, definitely it's sealed now. I have a little pressure release valve because I'm like super not okay with this exploding if it does. Not to mention, it's like, I don't know if these IR blasters were ever intended. So it's like, put some holes here, and then I sealed this with like a, high temperature, like glass effective. Well, it's glass, I guess. It's more quartz than anything. It doesn't matter. Point is, it's like meant to be, because it's getting cooled on one side, but like the vast majority of it, it's always like firing most of the IR in the inside of it. I know, right? Like, it's like a whole bunch of shit, right, that I'm doing, and it's like, yeah, but it's cool, and I have fun doing it, right? So it's like, oh, it's cooled on the outside, but the inside temperature, it's the right temperature. Baking it now, finally, And then it's like, all right, cool, it's baking. I'm gonna throw in some argon instead. Really? Yeah, well, I had to test it before I ever put the exhaust in there or ever tried to like do anything to it. Like legitimately, before I did anything, I was like, if it breaks, I don't want it anywhere near that. I don't want to have any troubles, you know. So it's like, all right, before I do anything, and it's like, all right. Well, I didn't. Let's get some argon in there. Yeah. So I pump it with some argon. I place the exhaust manifold. You know, I got the nice little like aluminum and some of this cushiony like silicone rubber thing that then like I placed some weights on top of it to like force it down. This little pressure release is at 1 atmosphere with argon inside. I'm like baking it, you know, making sure the powder coat and the high temperature silicone like all adheres after I had it dry off with the regular high temperature ceramic, you know, and scratch it a little, make sure it adheres well. Yeah, well, I had to mix up the caulking and the ceramic powder coat, right? And it's like, well, if I'm going to do that, I might as well push in some electricity too, right? Because that's just like a little weld, like, or whatever, right? For grounding versus like making it. Yeah, so instead of, but it's thick stuff, so that's like the paddle I'm using to spread it, you know, like to get it to actually adhere. Fill in any gaps or whatever, and then it's like done. I was done after that. It's for what it's worth. It's black. You know, like what's it gonna be? What color are you really thinking, right? You know what I mean? But it's like, all right. So then I got it baked, and it looked pretty good. Really? Yeah, I didn't have to do anything. It's real shiny. It's real shiny with like a nice matte to it. It's got like those sparkles, and then the high temperature is like the matte kind of satinish finish. It looks really nice. So, but I think it's like less than a pound. It's like honestly less than a quarter pound of an actual amount of weight that I added to it. But like, since I was gonna have to, you know, drill into the inside of the muffler and all that, it's like, you know, might as well get the inside looking nice again. I'm gonna paint that too. Screw it. And then I had to braze it up. So it's like I got this split, so I could do all of that, and then it's like it's for sure sealed. Like there's no way it's not. You know, and it's like, alrighty, all of it's one piece now, and it goes out to where it originally was. It sounds insanely different. It's a 4-1 with a crazy intake, which sounds like it's not even intaking because of all the little freaking valve things that are going on. Until you go like, what is this? It sounds like a clackety clack for this the second, but it's like a thump clack, like a gunk, like a, you know what I mean, for where the valve is, right? And then this into the exhaust for that is like a 4-1, right? But it's then like muted and then throaty roar, sort of like diffuse, no breath anymore, just loud thing. Except it doesn't sound like that. I know, right? It's like it's definitely lower dB, but it sounds so good. Thanks. It worked hard on that for what it was worth. That's sizing of the return and the distances that I had to get it to do that. Took a bit of figuring it out in CAD models, but then also I had 3D printing done with like a pulsing of from a compressed air, boom, 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 that I would pump into that little tiny 3D model thing that I had on a scale replica. So it's like it's gonna see it like this, and it's gonna see it this many times at these RPMs and all that. So it's like that's basically what the testing from the CAD to that would be, and like this amount of actual pressure for a quarter scale. You know what I mean? Like the volume and so on. So it's like it should be roughly about this extra pressure because instead of having, you know, heat, you know, which lowers it, but then it's like because of the extra oomph that heat can bring, right? So it's like this is the pressure, this is the and he's like to you know what I mean? Yeah, you know, I'm like, yeah, look at my Miata. Fuck you. Again, I don't think people really understand the that it really does sound like. At the, that's top end versus. Sounded amazing to me, for what it's worth. It was fun. I had a lot of fun doing it. It was a good little experience, and like the in all of it just makes it much less um, wiggly, jiggly. You know what I mean? Like it does. I'm never afraid of it falling off. It basically now has an inside and outside like change to it that mutes a lot of its sound, because that's like for powder coating, and then the silicone, and then like the ceramic effectively dampens like the outside, right? And then because I can just hook it on and then bolt it to the original spots, right? I then decided to like do like versions of the silicone, bushings with some washers, and then like got it to hook up that way instead of having it hang. I was like, oh, I'm going to use the studs. I'm going to get it a little closer up to the body, like tuck it in a little. That's where the tip goes now. Super fun. I didn't change anything other than like that resonator like changer. So it's like a transformer almost. It's like I'm gonna take a higher pitch to a lower pitch. So it's like this frequency, bang, bang to a boom, boom. You know what I mean? As I'll add in, it's a constructive interference, but the constructive interference changes it to a much lower wavelength instead of a much higher wavelength. It's the same amount of pulses, though. That's the reason why I did it. You didn't do anything to that tip, did you? No. It's the same tip. Sounds phenomenal. Thanks. You did ovalize it. Yeah, but that's because I wanted it to sit nicer. You know what I mean? It's not like a perfect. It's just slightly. It's a little oval. It's not going to change anything. I would really doubt it if it did. It didn't change nothing. No. But it looks nicer. It definitely looks nicer. Yeah. It's tucked in. It looks great. I do actually have like a little high temperature silicone there underneath the paint. Paint matched. Yeah, I'm not having this paint because this is a high temperature silicone ceramic, but then I have a high temperature silicone because like that tip can still probably get hot, and I just made sure like it's going to be extended past where the bumper is. I just don't want it to like curve back in. So that's why when you look at that, it's like, what is this there for? And it's like, there's nothing really about it other than making sure that the air continues past. And then like this little indent there, and this little, that's it. Like literally, it's just some indent right there that allows for air to try and get curved in behind where that is, so it joins in with the rest of the air coming out. No, I have no holes. They want to add a hole. I added no holes. It's not necessary. It's this little tiny thing that means nothing outside of for me and my own personal well-being, because I don't want to see if there is going to be anything from that exhaust. I don't want it to get on my paint. I don't want it to melt my paint. I don't want it to warp my paint. I don't want it to warp my bumper. I don't want anything to get too hot. That's all it's about. Meanwhile, you look at them. That's exactly what I'm actually dealing with. No, there is. Well, no. Wait, what? I mean, there are holes that go off to the side. Yeah, like underneath. There's air there, but then there's ways for the air to go around off. Yeah. nothing practically. Oh, it's a bifurcator that just takes air and then splits it down off to the sides. Really? So that way there's less air stopped there and it makes sure it cools the tip. Why? I don't know. They're weird here. I'm not gonna do any of that. God, fucking. I had fun doing it. Really? Yeah, I mean, it was a weekend little project. It's literally what it was. Yeah, it's a little aluminum. Just stay a little bit better there. Bolts. Yeah. Looks good. Looks fine. Oh, yeah. You did, yeah. Yeah. It doesn't sound different. I would, if you can hear the sound difference, that's amazing. I never heard a sound difference. Up to 160, yeah, but that's like screaming down a straight. You know, like at 120, it climbs. Yeah, it's like 120 miles an hour. I'm still getting more. Braking. No, that's a turbo with anti-lag. I don't have a turbo. It's all natural. With a lot of mods of intake. Yeah. And you're like, oh, yeah, the exhaust is. It's modded for. Yeah, no, I mean, for what it's worth, yeah, I'd have to go with there are a lot of mods on the exhaust, but not really, if you think about it, yeah. Oh, yeah. There are a lot of mods, but not really, yeah. I couldn't say it's a lot, but I couldn't say it's not. Medium, decent amount of noise. There we go, yeah. Wee-hoo. Tires help? No. I put better tires on it. You know, when I originally got it, they were pretty bold at that point, so. I didn't change those rims, I didn't do nothing. What it came with was what it came with. That's it. I don't like that though. Yeah, I don't care. I want out too, yeah. Yeah, the only other thing was the extra little radiator, which was, yeah, those things are small. But there's not a lot of room there. No. Like people don't get it. I had to mount this slightly further forward, and then I had to put like fucking fans there, and I had to put another fucking radiator between the fans. So it'd have to be thin ass, you know what I mean? Like, to make it all work like that, it was annoying. But it was worth it. Why don't you just get a better radiator? Because that one was free. That was free. I was like, yeah, I'm going to do this thing. It's aluminum! Oh, right, yeah, no. Well, I mean, the steel is still, it doesn't matter, I don't care. You can get steel, you know what I mean? Like, it's, whatever. They don't understand the shroud thing, or like, I have to mount this to something. Even if I put aluminum sheet around that, right, and then I still have to mount it to something. So it's like that's steel plate that I just got cut into the right shape and size. That's all that is. It's a bar for what it's worth. Yeah, yeah, I didn't want to say that, but like, yeah. It's like, this is aluminum bar. Yeah, like plate bar. Like a little tube, actually, really, is what that is. Yeah. Like, literally, this is a tube of aluminum, this is a tube of aluminum, this is a steel, like, mount to mount. And then it goes to tube, and then, like, that's, like, where I also have the ability to mount the fans to, besides just the radiator, too. And the radiators are then able to mount to, like, the steel and the tube. And then I have the shroud aluminum sheet that's around that. Well, I didn't extend anything with the front bumper. Wait, what? Yeah, I didn't. It still fits within that. I didn't even have to change anything in terms of, like, outright, you know, where the hood mounts or like anything like none of that. There's some slight. Actually, there's no clearancing issues. Like honestly, there was really barely much I had to do for what it was. It was just like the right mounting and the right like little placement of that for a little bit further forward to a little bit further. You know what I mean? Like that's really what it turned into. It's like this little pack, like is able to mount to that like just the right way kind of thing. I do have to cut certain things off to make that work, but like it doesn't look like it's any different. It looks like it's the same. The radiator was good, both of them. I just left it alone, you know. It worked. I never suffered any overheating. I never ever took it for long periods of time at that very top end at very high speeds. I'm still on a track though, but like it never overheated on a track. That was fine for me. I had a fun time doing that engine. Yeah, actually that one was like a nice little project at the time. The tube thing was really nice. I mean, that I can mount the sheet that I was using to that tube. Like, it was very sealed. Like, not like, oh man, I got good tolerances or gaps. It's like I'm sealed with like an actual like silicone, like little bent, sort of like they use for computers, right? So it's like I was able to mount all of that with a bunch of these like bushing, kind of like sound dampening, seals. I rolled it a little, tack weld, or like, well, like spot weld really. And then it's like, all right, and then I'll get it to braze and then like real weld, and I'm gonna thicken it up in a couple of spots. So I placed a couple of actual other sheets there, like little pieces. Put a little bit of holes, a few holes, like small ones, and then it's like that's brazing rod in between, and then also in those holes, and then like heating it up, and while spot welding. So it's like spot welding, it's heating it up, and heat it up a little bit more, and then it fills it up. And it's like all one big old piece there where it needs to be, and then it's bent and made more rigid with more of those little tinier pieces, but then I'm bending, rolling it in those areas, so that way it's structurally stronger. And then it's attached to tubes and steel plates, you know what I mean, like aluminum tubes and steel plates, and so like everything's like way stronger there than before, much stiffer than it doesn't want to bend, damn bastard. No, that one's pretty fucking simple. Wait, really? Well, cross member like anti-roll bars, stuff like that, is not insanely impossible to make. Wait, what? Yeah, it's really not. It's pretty easy to do that. So it's like, do I want to do this? Yeah. Like, I'm never really gonna need it. The trunk got one. This is the kids. It's like, we're doing this. It's not gonna. Okay, all right, we're doing it. Yeah. Got a cross member and then an X member from each corner for the engine bay. So it's like it's going from one suspension area to the other, but then like from that suspension area as well to like the other where like the headlights are. And then like because I had this stiff tube stuff already there for like the double radiator, I didn't need to do that. So it's like hidden. And then like I had another version in the trunk now as well, where it's like crossed over, and then from one to the other where like the ends of the chassis would be, and so that would be like its own version of a little stiffer in terms of like the chassis, and then roll was like another version of a similar type of thing. Instead of getting anything built or anything like that, it's like, well, it's going to have to go up to here if it wants to roll like that. So if I mount it from down here and I had to drill a little bit and seal it a little bit with like little diaphragm things, and it's a bearing journal kind of thing. So that way, like that aluminum would then go from one suspension, roll area that would be able to do that to the other side of where the top is, yeah, of the suspension, and then same thing. So front and rear got that on top of the top chassis stiffening, right? And so like it is very much able to be stiff. It's a fun car. I thought so. It was pretty easy to like kind of just buy aluminum tubes and do that. Yeah. They're just aluminum alloy tubes, yeah, extruded. They're fairly cheap. Yeah, that's it. Yeah, they're thicker than like what they would probably give you, but like that's it. You bent that. No, they're extruded. Wait, what? Yeah, they're extruded. So like what that means is like while they are tubes, they're extruded. That means they're stiffer because they're extruded, because they're like pre-bent already. You'd be looking at it like, is it a square? No, it's a round extrusion, but yes, I can understand why you think that. No, I wish I could have put another thing around it. I can't, but it is what it is. I can weld and braze and do all the like little, getting it screwed on and then brazing around that and bolt it or whatever, right? So it's like I was able to do all of that with like basic extrusion, aluminum tubes. It worked out pretty well, especially when it's like, well, it's sealed anyways. You know what I mean? I don't have to care. Yeah. They got rollers and stuff. You know what I mean? It's like, I don't really need. I'll just put a fucking other tube around that, like an actual tube, and that's in the bearing area that goes through. Everything worked. It was far stiffer. It weighs way more, for what it's worth. Yeah. No, that one was fun. We had a basic drill, like a drill press, right? Right, and so it's like that was, well, they're vented anyways, so now we're going to drill with inside of the vent areas, and then we're going to slot alongside of the curve in between, starting at the vent area and then in between where the drill part is, and recess everything, and then try and make it like a little bit less towards the center and a little bit more towards the ends, kind of a situation, and different size diameter holes for that to really work out. And so we did that front and rear. We didn't change anything with the calipers other than like we made the calipers get, and these are real, just straight up computer heat sinks, vapor chamber heat sinks that we just fucking stuffed onto the thing. Yeah, no, yeah. We didn't find it, well, for what it was worth, we could have. I didn't do it. But it's the standard, brakes, yeah. It's hydraulic brakes, but it's like, yeah, no, that means you did do something with the lines, though. Yeah, well, kind of, a little, not much. Like, geez. It's like, no, you must know all the things. I'm like, there isn't much to tell you. Like, the lines are where they are. Like, there isn't, like, a lot that I could do there. But if I can make it such that they don't boil off as easily, which is what I'm doing with the calipers, but also like the lines basically have their own little version of heat sinks that I just attached with like a little plate thing that fits onto that and around it. So it's like bolt, and clamp it with a little bit of compound, and then they're like just fins that are in the, so that's all that is. I mean, yeah, like right, that's it. It's just like a really fun little Miata car, but it weighs more, like in all aspects, dude. It weighs so much more. Like the aluminum, like it's like this weighs more. Like everything started adding up to weight, and it's like, man, my performance. Sure, yeah, like I won't lie, I did go faster than the original that I bought. By far, around a track. I can brake faster, sooner, or later, really, So it's like I can brake later, you get on the power faster. I have just more outright to do, to be able to go around the track, but like, you know what I mean? Like, it's like, this is like maxed out mod from like knowledge of like stuff that people have done and works without getting deep into the crank, or porting even larger and get even more, like nothing extraordinarily extreme has occurred. It's still fairly extreme, but like all within the scope and context of just people could do this with like some basic stuff, right? All that is really. Like, that's all it was about. It's like, no, this is like for the exhaust and I can carve off some of that. I didn't even touch the engine block or the valve covers or any of that to try and lessen weight. I actually kept adding weight. You know what I mean? Like, everything, like even that intake manifold and stuff, it's like, even though it's aluminum, it's still more weight, Like, I have more valves now, right? All sides, right? So it's like, that's straight up just different than you would have thought. I have like way more weight towards the front now because of the radiators, and then I have all this anti-roll chassis stiffening stuff, and it's like, it's same standard size tires, not bigger and wider in the rear or anything. I didn't do any fender rolls, I didn't do any of that, right? So it's like, it's a heavier manifold or exhaust, right? Because I had to add stuff in and materials and bake it and all that. But it sounds wonderful, right? And I had to add stuff to my exhaust. Like, basically everything weighs more. And like, I'm looking at my calipers like, yeah, no, I basically added back that material weight in just fucking heat sinks. So it's just like, well, it can stop faster just fine. You know what I mean? Like, I can hit those fuckers hard and not have to worry about boil over, right? Which is great. It stops faster. Great, right? I can also get on that power, and I can get to a higher top speed and accelerate faster, which is great, right? But it weighs more. Like, everything weighs way more than it did previously. It's like, I added on another tube for my intake for RAM. I have the valves. All of it just weighs more. Like, that was my biggest gripe about the whole thing. It was like, I'm not really making it much better in terms of any weight. Like, I'm adding more and more weight. It's for sure more weight. But that's fine, because it's like safer now. It handles better. It for sure stops better. Like, I didn't do anything really to the suspension spring rate. Like, I'm not gonna do it, like, at all. No. They're the same standard. I didn't. No, because there's a diaphragm. Yeah. No, I figured. So it's like, this is a tube. As it goes up, then there's this spring of air that it presses up against. And then I have a fluid there on the other side that it has to push as it goes backwards. It's like, that's on the other side, but then also it's around it. It's like, spring presses in, this doesn't really ever move, but then spring goes back, and then the heat from that spring compressing and everything, but actually as it expands, it's then going to have like this little heat sink thing, heat soak into the hydraulic fluid that I'm using, right, with the little thing, and then, which is a tube within a tube. It's literally a tube within a tube. But it's like this, once it gets hot, it's a vacuum kind of thing, like this diaphragm here, and there's a vacuum on this side. So it's like, once it goes in enough, it gets hot enough, that vacuum will then expand, and then it still has the heat sink fins there. But it's like, this is all really very significantly covered in this center, like up inside, like the trunk effectively, and like where the firewall kind of is, tucked away. So like, that way I can hit both of them on both sides, still have air pass around it, and then the trunk area is kind of another version of the same thing, where it's like really kind of underneath instead of inside the trunk. It's underneath. but then like both sides can use this dynamically and still get the same spring rate and spring pressure even when both of them get locked up, right? So it's like that's where like that weight had to go to with the freaking tube thing that I had to do. But what it means is like, well, I have this spring and then this spring too, which adds to that. So it's like now I have a stronger spring, and then I can also disengage that with a little flip of a switch by going like, no, I'm just gonna drive around like a normal everyday street, and then it's like I'm on track, so track mode turns into like stiffening and you know, like all that. Because I was sick and tired of seeing this body just go like, yeah, fuck you, gunk, like just straight up, I'm this close to the fender well. You would be hitting it if it wasn't for the stops that are there. Bonk. God. So it's like, this no longer happens. It still loads up, but it's like, nah, it's fine. And then same thing with the rear, it still loads up, but no, it's fine. Yeah, no more hopping, no more jittering, no more any of the stuff that I'd have to be afraid of. Right? So it's like, now I got stiffer suspension, I got better brakes, more horsepower, more torque, more bottom end, more top end, all the ends. There's no more ends more I could give you. Got a better sound. It'll never have to, well, maybe. I've never hit a track that I've actually had like any boil over from the calipers. That being said, I have gone through brake pads for what it's worth fairly quickly. Like that one was a wake up call fairly fast. It was like, wow, you can really go through brake pads. I should actually buy like decent brake pads. I was like tuning it with the double flute, like the double, you know, velocity. Yeah, like that's all that was, right? And I was like, well, I've gone through all of my brake pads. I'm gonna get like decent brake pads. It's like, is that your own? Where did you buy those? I'm like, yeah, I made them. Like they came with the car originally, and then I made them. Yeah, I love that. Like, I actually, genuinely though, yeah. I made them, and it was a pretty fun little project. Especially when it's like those little slots. Those are fairly easy to make with like a little Dremel and a rig as it spins and it goes down and you spin it, and then like, you know, you effectively just have like a different Dremel bit for like the widening and then shrinking as you go down and as you turn it. So it's like, and then you start the slot and then you like, and you know that as it, right. It's a Dremel, it's a rig, you just have to build it. If you don't know how that, I mean, that's all it is. It's same thing with like the drilling through the brakes discs, yeah. Like, that's all it is. It's just like a little drill press and then a little recess, and it's like starting at a wider hole towards the base, and then more holes that are smaller at the edges. That just evacuates heat faster, as it can turn into a pump. So like it'll suck in air and then it'll pump it out towards where the vents are, and it has more places to vent. And it has more surface area in between that suddenly is there to help evacuate heat. Oh, I wish I could have added. I didn't need it though. It never got hot enough. Like I didn't need any air cooling. Like I just didn't need it. You know, maybe someone else. I just never had it overheat. I never hit them. It can only go this far with pressure, right? Like that's all I can do. Even with the ABS, trying its best, right, to help me be able to like slow down. You know, it's like it can only do so much with the tires, and it can only do so much with like ultimately the stickiness and the level of braking you can get from that. So that's it. But I have seen the vapor chamber, you know, heat sinks get pretty hot. They never bent or warped or any of that, which was great. That was nice. Yeah, I like that part a lot. Yeah. But like, I've seen them get hot, like not like glow, but like you get like at the little thermal thing, you know, like the temperature gauge, you know, and you shine it at it, and it's like, what the woo, hot. I've seen them get quite hot, about 200 degrees, but Fahrenheit. So it's not boiling, but Fahrenheit. Same thing with the other heat sinks where like the line coming in. It's like I've seen those get up to about 150-ish degrees Fahrenheit. It's a little hard to measure. I had to like put like a little, you know, something I can actually then use to scan it. Because it's measuring IR, right, and all that, yeah. So it's like that meant, you know, it got pretty dang hot, right? But it's like the brake discs were fine. They never glowed. They never got like, you know, red. So, but they definitely were hot though. Yeah, but not super hot. You know, right? Yeah, it's that like no. I definitely improved them, but I never had them overheat, which was fine. That was the whole point. Yeah. The radiator tech thing is just like a double radiator. You just put a radiator in the rear. Like a lot of that's like basically that, except for like you can actually put it underneath. Like a lot of people don't think about that, but you can 100% put a radiator underneath the vehicle, like in line of the center, and just have it like have a different separation with a plate and air coming in from where the air is coming in, you know, for like any of your, you know, front, and then have it go through that, and then have it be separate from like the exhaust area. And then, while yeah, sure, you lose some thermal efficiency to a degree, you can always have it be now longer and thicker, or have multiples, as you can angle them and then have different fin arrays to allow for air to still pass through. And you think that you can continue getting heat evacuated from the engine, right? Like, oh, you stack it, it's like it's going to have way too much. Like, you were just talking about computers. You don't have nothing in terms of the knowledge. Like, they do it. They've done it. It works. It's not that bad. Like, there is a degree of between series and parallels. So it's like you can do a parallel of two, and then you have to do from that into a series, and the air really just turns into from like bottom up. And then you'll usually have like a little bit of air from the side, but then some of the air from that go into the next one. And you can usually get about 4 to 5 of those radiators to work that way. Hey. I know. Well, no, because they wouldn't. Like, no, I can cool a Bugatti Veyron with series and parallels of this W16 quad turboed behemoth of an engine with like little tiny side vents and fucking shit like that. I can cool this monster over 1,000 horsepower engine with these tiny little radiators, right? But no, I could never do this. What is this? I say lame. I have a big air intake over here. I can easily do this. Yeah. He just didn't do that for... No, I sold... Well, the kid got the Miata. Eventually she wanted to sell it for something else. It's her name, her title, her stuff. It was bought... she didn't pay for it. It was fine. It was a work of love. For what it was worth, it's like multiple of my daughters shared that Miata. We had like a couple of them that wanted like motorcycles, and I was already working on a couple of them, so you know, yeah, that's what that was. No, that was well, they you know, they liked riding with dad or mom or you know, one or the other. You know what I mean? Like that's what it is, and so eventually it turns into that. So it was just a wholesome thing. It was genuinely like we like motorcycles and cars here. That's what we do. We just like enjoy doing things, right? So people were like, no, whatever. I don't care. Most people kind of understand that it was nothing weird. It's just a fun thing. It's super fun. Okay. No, oh my god, motorcycles are like super fun to work on for improving efficiencies of like actual air intake efficiencies. It's so different. If they're a carburetor versus fuel injector, so different. Like a massive, like overhead cams versus pushrod. Oh my god. Uh. Then there's like, okay, I need to be able to like have this exhaust different from like, and so much more efficiency you can gain from like what they give you. What they give you is not that great. Like, just think about the ram air. Like, most of the air comes in from one side. You have a ram air right in front of you, off the sides of the tank, and like right down to where the little radiator is. Right, like that's a ram air right there. Like, there's nothing stopping that from happening. You know what I mean? And then same thing with the little teardrop coming in with the little overhangs. Like, super fast. It very quickly becomes like so easily done to have like this top instead of a rear, you know. So it's like it comes in from the sides, but then I have like this top rail that I bifurcate from that, you know. And so like this you know, the inside manifold tube is like more of a teardrop shape. Get these little wave guides, and then it became much easier to get like from this over to, because it's parallel. So it's like this goes over to there, or it's like it's crossplane, right? So like depending on what it's doing, it's like this is all I have to do to make this work. You know, it's like do, and it's like, no, yeah, no, that makes total sense. And then the exhaust is just gonna come off like, I can easily do that. There's nothing stopping me. And it's like yank this over here, and then like put on the little velocity flute, and then and what do you know, a little massage, and it's like it's gonna feel nice, and it looks nicer for what it's worth. You know what I mean? There's like no need for any of the turbos or super turbos. I finally got like just a basic ram air. It's like I'm gonna get like the basicest of that I can for having air come from around the sides, or from the bottom and around the sides, to go up and then through that, and then around and then through the heatsink fins. It's like a lot of them don't really have heatsink fins, but it's like I need to do something to mount this new intake anyways. Heatsink fins. What? Yeah. Yeah, no, thermal epoxy compound and some heatsink fins. Air cooling a little bit. Yeah, just a smidge. Just scotch. You know what I mean? I'm gonna trim down that area with a little plate, and then I'm gonna thinner here, and then put them in line, and then I'll just a little bit of extension, and then like a little bit of it's like, oh, it goes around like a little teardrop now. I want to push some of that air into like where the exhaust manifold is anyways. I mean the intake manifold is anyways, right? So it's like, alright, I'll just, you know, and then like the exhaust is going to go down off to the sides, and so this is like a cool equaling tube header, easy, like little, you know, push it from, if it's crossplane, that'd be like 2 and 4 off to one side, and then 3 and 1 off to the other side, right? It's like, here's a little, well, I needed the heat shield, so you know why, like this totally works. Right, you know, super fast, like immediately. It's like, you know, actually, I needed that anyways. It's super fast for me with how quick that turns into something I do. So it's like, well, you know, I don't really need, and then like this can extend off that way, and then parallel with the, okay, so then it's like, that's what I'm going to set it up as. And I look at that, and then I, instead of having this kind of valve thing, instead I have like valves at each individual tube instead now, and then I have like that exhaust that gets stuck there that goes off into the other side that's firing off into its exhaust. So it's like, think from 2 and 4, like 2 and 4 will go into one end or 3 over on the other side, and then 1 end or 3 will go into 2 and 4 on the other. That way I don't have to do anything with valving at all. It's just, well, I do, but I don't, right? It's like that little amount of extra, whatever exhaust that's trapped there, because they still have a valve there. But as it's going, it's opening, and then like this Bernoulli principle effect then takes over as it's rushing past, and like that then joins in, and that's my valve setup, and then it's like duels off to the side. It's so fast because it's like, oh right, well this means from this two into one kind of thing, it needs to be about this diameter, and those have those individual, into this level of size. And then that 2 into 1 can then have this joining from 1 and or 3 over here, and then like that looks like a 4, and so like even though there's 2, it looks like 4 into 1. So then that goes off into basically a glass pack. So it's a I literally got real car high flow resonator, for sound, right? Like a high flow resonator, like just regular big boy, right? Hybrid, because it's not a glass pack, but it's like that, right? But then that then goes off into the glass pack that's there. So it's like I got the high flow resonator into the glass pack that then has like, I put a little few holes in where the glass pack is, and then same thing with the high flow resonator, where it starts having air come out around the sides or whatever, because like there's a tube that has a bunch of holes in the center that then go outwards, right? Yeah, and then like that produces an up and down. Okay, but if I do like a little bit of holes around that edge that goes into the glass pack's holes around its edge, then that has like a little tube that surrounds that, and it looks like it's all one piece, super cool stuff. But then like that all combines into the exhaust tip of the glass pack that then goes into like a standard, just, little stator connect thing, like little, like I just weld that, right, and then that goes and curves it. Well, it starts off at that whatever size it is, because I have to combine both of them, and then it gets a little bit wider, a little bit bigger, so like that size, and then it starts flaring out. Instead of like horn, like an actual horn, it's more of just, it kind of curves slightly out, like a little wider, oval, but then it's definitely like a very low oval, mostly just circle shape, right? It's wide, sideways, but it's like, oh, that doesn't look very good because it's sticking out like little, it's sore thumbs. I didn't like it, so I then made it vertical, and then I just tucked it in a little bit closer, and it was like, this looks phenomenal. It sounds really weird though. Yeah. like like real, like instead of breathy, but it's still got a little breath. It's like very loud, like, but then it's not. And instead of having it do that resonate and then like make it like baritone, it's just gonna take that and then like just exhaust it as fast as possible. Because like that 3 into 1 went into a wider area, into like the muffler area. So it's like it's this size diameter that's starting to curve over to the side, right? And it's like during that it then starts to horn, right? And then it goes and then has like its connector, right? Like little bolt and then all that. So it goes two of them off both sides, yeah. Super fun stuff. But I then had to do the the intake stuff, the injector timing and all that. Yeah, so it's just like, well, we're going to have fun with injector timings and more. Especially with the Ram Air, which I love. Honestly, I love the Ram Air. The fuel pump was a whole thing, though. I had to get a fuel pump for the thing, and then I had to get, like, the dynamic balancing for the fuel-air map. So it's just like, all right, let's do it. And climbed up a solid, ridiculous 50 horsepower. Like, serious, ridiculous stuff. like 50 is a lot for like a basic like little engine, right? And like that's all that was. You get one more, and like you'll fill one more. You'll fill half. I mean, hell, you get 5. Like that's a huge difference, right? I get 50. I get actually a little more than 50, like 52 actually, but like 50 more horsepowers. You know, way higher or lower end than I did before, especially when I'm trying to launch, which well off of a corner instead of like at a street light or something. So it's like that would be a real fucking scary moment. So I got my screamer. It was fun. Well, it lasted for a bit. Really, I'm within the specs of dB range for like motorcycles, okay? But it's like, right, yeah, no, because those are big fucking glassback and resonator. Oh, yeah, they are. They're huge. They're like these little, like, tiny little exhausts that go into like that 4 into a 1, and then it's like they're off to the side. And it's like you would think that they wouldn't be very much, but then I fucking fit them to the thighs of this thing. And like that's big, and then that's big, but it's a big into smaller-ish because the glass backs are typically a little smaller. Yeah, and so it's like that then has to like have that outer casing to make it all look the same size, and so it's like that I tucked in as far as I could, and it's like. Getting that 18K going. Like, you think I can't do 18K? You don't know. Fuck you, I can do 18K. I won't be fuel limited or air limited. Give me this sucker. It's balanced enough for us. Got to get the harmonic balancer out. Yeah. Oh no, yeah, no, the dual harmonics. I had to get the dual harmonic balancers. Wait, what? Well, yeah, because it's like one. Do you get like the up and down counterweight? Yeah, actually, I did do that because at that point I was willing to like start knife edging things. Right, I was like, I'm gonna have to put this on and dunk. Yeah, I'm gonna put this here, a little gear there, a little, this is our actual oil pump, the harmonic balancer. I'm gonna get it up the fucking like little up and down, double counterweight. I'm gonna like really remove that counterweight just quite a bit. I got my dual harmonics. It was like, based upon like, because this one was a crossplane that I was working with versus parallel, which I prefer parallel, but like this is what I had, so another crossplane. Right, but it's like, it worked really rather well, right? And so it was like, I got my screamer, dung, 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 1, 2, 3, 4, that's how a screamer works, right? So, and it's like, that means I need this to do here, then this one over here for the other harmonic balancer is then going to pulse, and then this one over here for the other harmonic balancer is going to pulse, and this one over here is going to pulse for that one. So it's like, and then this up versus this down over here for the counterbalance, counterweights, suspension thing for like one, and then like the next one, and then the next one, and then the next one. So it worked really rather well, just dividing it by 2 instead of having one for each one, because I only needed one to go up and one to go down, and then the balancers would work for the other areas in time for the crossplane. Yeah. I needed the rods for the balancers, or the gears, really. So it's like, here's a little tiny harmonic balancer. You mean my oil pump? Yeah, why do you have 2 oil pumps? You wouldn't get it. No, I mean it. Like, you probably would if I had to explain. I just don't want to explain it right now. That's really what all that is. And then I had to stick in the little counterbalance weights inside of the crankcase. With the rods, yeah, which had to go like horizontal parallel to the crank, which is like, where the fuck am I gonna put the motherfucker? It was like I found a place to do it because I needed the balancers anyways. Right, and so it's like these are my new like um, oil pumps, and then I have my counterbalance for back and forward, right, as it will do that. You know, and then like they'd be balanced based upon, right, because they'll spin, and then they'll go forward, and then they'll go backwards, forward and backwards, right, and that's how Formula One's like old suspension would work. So, right, but I wanted to do up and down, right? Why didn't you? Yeah, I know, right? Yeah. Because it turns out, like, if I have that with the balancer spinning that way, and this moves like this, and this moves backwards, and this moves... So, like, with the balancer and everything, it meant that it was fully balanced from those rotations, and then side to side, I couldn't really get around. Like, I could only do vertical, and I couldn't do vertical in that fucking, like, little tiny crankcase. Like, I wanted to do vertical, but I'd have to get a whole fucking thing that I put over it to make that work. But it would have been easier if I had done that, truthfully speaking, a little bit, yeah. And up and down. But it's like, I'm gonna have that shaking regardless, right? And it has to spin as it does that. And so, like, then I have a counter spin to this counter, you know what I mean? It's just this... It's like not very neatly packaged. That's really what it was for me. Like for me, it was like just not very neatly packaged. And like that small movement for the rotation is very minimal for me. So, like that's all it turned into. It's like, yeah, no, there's like very little actual. I don't feel side to side at all. Rare. It's because it rotates for what it's worth. Yeah. Like you really don't notice it. Nah. But the better part of that given system was that it was like, oh, I can now tuck in everything. Like the intake manifold got tucked in much closer to where like the heatsink fins that I added onto it. And then like that all meant I was able to get it all tightly packaged, and the exhaust was able to be separated with this nice little, exhaust sort of like downward sort of firing setup into all those tubes, because tubes being bent like that, not super hard. No, not at all. There's like stainless steel? Nah, we'll just go with regular mild steel, and then we'll just put like a secondary tube around it or something. We proceeded to never do it. Just wrapped it on the outside, and then put like a heat shield around that, and then it was like, oh, that'll push air around that, right? And then into the little heat sink. Whee! 50 fucking horsepower, just some better intake and exhaust. Sounds insane. Like, genuinely, like, when you hear it, it's like, what the fuck is that? It vibrates like nothing. Like there's nothing there. You know what I mean? You can rev it, and it's like, I hear the hell out of it, but I don't feel nothing between my legs now. Which is like, oh, what do you know? I need stiffer springs for the exhaust so I don't have any valve float, right? And so like everything got switched for valves, and then it was just keep climbing it, just keep climbing it. Like this was before with the ram air and everything, before we got it to like a higher RPM, and it's like time to get better injectors and all that to just fucking fire it properly, because like, all right, we'll change this with the lobe. Well, lobe-ish. It's more like scavenge more than anything. And then we put a bucket there. So like that was our way of like extending the lobe duration. It's like, we're going to need to go up to a higher RPM. This is really only going to go up to 9, maybe 7K. It's like, 18K. What's that? 18K happens. We're going hard. We got double injector shit. We got scavenge going on. I've got like a big spark plug thing going, I'm just like, coil packs, EC, yeah, you'd think it'd be a big block. It's not a big block. It just does really high RPM and really good intake and exhaust. with ram air. Yeah. Oh yes, no. I have to specify that a ram air with a whole like double capture system of pressure from that like you know long and short runners that then like actually act like a capture and flow increase to the given and pressure amount to the given intake. Right, like that's all it really was, and then I had to port the whole thing. Like lots of porting happened. Much bigger ports started occurring. Like much bigger, yeah. Like these fuckers really got better exhaust and intakes. I had to. I had to get that the crankcase vent thing that I talked about. You know, like the little venting and then like moving that around, and it's like, oh yeah, let's have fun. Like all told, I'm at like 70, roughly, yeah. You know, a little higher, 72, but on average, a 70 horsepower increase by the end of all of that. Just, yeah, yeet me through the air. I had fun. It was fun with the kids too. The whole family had fun working on those fuckers. It was ridiculous after a point. They could hear the damn thing just screaming. You know what I mean? Just fucking fun. But the biggest real main issue wasn't sound, because I was within spec. It was mostly the fact that I burned fuel. Like advancing timing, delaying timing. There's a lot of fuel here. Yeah, I mean, yeah, it's for fun, right? It's like I'm just meant to have fun with it. That's all it was for. So it was one of those things where it's like this was like genuinely or like a single kind of person motorcycle. You could have a second person on it, you know, but it's like this is the very definition of overkill in many aspects. It really wasn't meant for it. It was like, yeah, no, it's like this has like maybe 100, and it's just like 170, best I can do. Where are you going down that highway? You want to do 180? No. No, I'm pretty okay with no. I had so much fun though. It was fun. I get that, but you're also scary. You didn't know the kids had fun? They were more scary than I was. They were like, I want all the little nitty-gritties. They got it up to about 200 horsepower from this tiny little fucking sucker inline 4. And like, that's pure and simple from like just slight tweaks to my intake and exhaust. Like, oh, you know, I'll just put an extra valve there. Oh, I'll just put like this thing here instead, you know, for my intake. Like, and then like a wider ram, and then like a better like curve, and then like all of this like this bifurcation to like this intake side bifurcation, and then just straight up across like rail sort of situation instead, that made it so that it always just kept flowing around perfectly, vortex, and then move on, and it's like whoop. Anyways, that one was fun, significantly. Motorcycle, not really a possibility. Give me a second. I'm gonna finish this.